All right. So I just want to go through kind of the basics of what we will be doing today. So first of all, it's in week 40. It's the same kind of stuff from last week. The same three things, which are we're going to be going through actual problems today of the study guide. We're going to be going through that for the next 2 weeks. Just a reminder, there's no more retakes and no more late work. I'm not taking any of that anymore. All right. So this is the answer key. Sorry, this is not. So the study guide I'm going to be going through is this one. You guys don't have a hard copy unless you've been to the school to get one. You guys have just virtual copies. Still is important that you do the examples with me as we go through. People in person obviously have a hard copy of this already, but you don't if you haven't gone to get one. So please make sure either A, you print one, or B, you go get one. I mean, either or works just fine, but it's really important that you kind of have a hard copy, so it helps when we're when you're doing this, when you're studying things like that, or at least get a hard copy of the reference sheets too. Okay, questions? All right, so let's look at the study guide. So first is we're gonna go through the first page, number 1, that says write the products in the correct states of matter of the following problems. Also balance the reaction. So make sure you have this, and also make sure you have your reference sheets out, because these are going to help, especially page 2, since right now we're looking at putting products together. Okay, so first things first is we have to separate and know that which are part of which. So Al is separate from SO4, Ca is separate from OH. And remember, the thing is outer, outer, inner, inner. Okay, again, it's outer, outer, inner, inner. So first of all, Al. Okay, you guys can see it on the screen. What is the charge of Al that you guys see? What is the charge of Al? 3. Yep. So the charge of Al is positive 3. So we write the charges, because before we put them together, we need to know the charges of each. SO4. SO4 is a polyatomic. What is the charge of SO4? Anybody? Charge of SO4.
-2.
-2. Yep. Charge of SO4 is -2. Ca. Let's go back to the periodic table. Ca is right here. What is the charge of Ca?
+2.
Mm-hmm. And lastly, we have OH. What is the charge of OH?
-1.
Mm-hmm. All right. So now that you have your charges, now you can do the outer, outer, inner, inner. So reminder, you only bring one of each over, okay? You only bring one of each over. So you don't bring the 2 ALs, you only bring 1 AL. You bring more if you need more. So AL is +3, and then it's going to mix with OH, which is -1. So Do we need more Al? Do we need more OH? What do we need more of? How do we balance these charges? We need to balance these charges. How do we do that? Anybody? How would we balance these charges? Anybody remember? This is not, we do this often. Come on, we have +3 OH minus 1. Would we balance these? Would we not? Are these already balanced? What do you guys think? Anybody? Come on, guys. The more you, if you don't participate, we are here for a longer time. If you're not paying attention, that's kind of going to hurt you in the final. So come on. How would you balance these? How can we make these so when we put them together, they're even, they're evened out? If Al is +3 and OH is -1, what would you do? Somebody's got to remember. Switch them. What do you mean switch? Switch what? Somebody said switch them, but switch what? What do we switch?
The charges.
The charges, yeah. So we can switch the charges. So we can do that. We can switch where 3 goes with OH and 1 goes with Al. So we can say Al is by itself, and then we have OH, and then we have a 3. Right? So that works as well. Or you can say, you know, we need more OH because obviously we only have 1 Al. All right. So let's keep going. Then the inners. We have Ca +2. We have SO4 -2.
That one's fine.
Those are fine. Yeah. Those balance out. Right? Because +2 -2, those actually balance out. So you just need 1 of each. Okay. And there you go. If you don't remember how to do this, you really need to practice this. Okay, guys? There's a lot of practice for this. If you didn't know how to do this, you need to remember how to do this. There's a lot of practice here for this stuff. All right, so we wrote the products. Now we need to write the correct states of matter. How do we do that? We go to page 5 of this. The solubility rules. Predict whether something's soluble or insoluble. Those are your states of matter. So solid is something that is insoluble, something that won't dissolve in water. Liquid, on the other hand, is water itself. Most of the liquids that we see here will be water. Gas is gas, obvious. G is gas, obviously. We're not going to be working with that too much. And lastly, the other one that we're going to be working with a lot is aqueous. Aqueous means it is, I meant to write soluble. It is soluble or dissolves in water. So the majority of our states of matter will be S or AQ that we will be writing. Again, the majority of our states of matter will be S or AQ. S means insoluble, it won't dissolve in water. AQ means it's soluble and it will dissolve in water. How do we decide that? We decide that based on this sheet right here. Okay, so let's look at AlOH3. So we have OH. OH is considered an insoluble salt, except when it contains Na, K, Ba, or Ca. Again, OH is considered insoluble unless it contains Na, K, Ba, or Ca. So we have Al. Al is not an exception. So OH salt is actually insoluble, so we would write an S here. Again, because OH is considered insoluble and Al is not an exception, it is considered insoluble, so we would write an S. CaSO4. So we go back to this sheet. SO4 is considered soluble. As the title at the top says, it is soluble. It's soluble except when it contains Ba, Pb, or Ca. It's soluble except when it contains Ba, Pb, or Ca, then it becomes insoluble. In this case, it contains Ca. So again, it doesn't dissolve in water, so that means it's insoluble, so it's a solid. And that is your correct states of matter. Questions so far? Lastly, we have to balance the reaction. How do we do that? Well, we have to take down every single element down. So we have Al, SO4, CaOH. And we have to decide how many we have on each side. So in the reactant sides, how many ALs do we have? We have 2. In the product side, how many ALs do we have? We only have 1. In the reactant side, how many SO4s do we have? We have 3. In the product side, how many SO4s do we have? We have 1. In the reactant side, how many CAs do we have? We have 1. In the product side, how many CAs do we have? We also have 1. In the reactant side, how many OHs do we have? We have 1. And finally, in the product side, how many OHs we have 2. My bad. In the reactant side, we have 2. And then in the product side, we have 3. I forgot that was not looking at the 2. Okay, so this is obviously an unbalanced reaction. Meaning the ALs don't match, the SO4s don't match, and the OHs don't match. We have to have the same number of ALs in both sides. We have to have the same number of SO4s on both sides, and we have to have the same number of OHs on both sides. So the rules for balancing reactions are the following. You always balance what's in the most complicated situations first. You always balance what's in the most complicated situations first. What does that mean? It means that things like Al are not in complicated situations because we have 2 and 1. SO4 is not in a complicated situation because we have 3 and 1. OH, however, tends to be in a complicated situation because we have 2 and 3. Why is that a complicated situation? Because there's nothing you can multiply 2 by to get to 3. Just like there's nothing you can multiply 3 by to get to 2. Okay? You can't multiply 2 by something, a whole number, to get to 3. So what do you need to do? You need to figure out what the whole what number can both 2 and 3 go into. Meaning, what is the least common denominator for 2 and 3? Can anybody think of what's the least common denominator? This is basic math, guys. Basic math. 6, exactly. Least common denominator is 6, which means that OH, okay, both sides, we need 6 on both sides. What number can we multiply 2 by to get to 6?
3.
3, exactly. So that means that we need a 3 coefficient. Use a red here. We need a 3 coefficient here. So this 3 not only goes to OH, but it also affects CA, but that's okay. Okay. This 3 will get us that OH to 6. However, that CA will also be affected, and now we have 3. Now, what can we multiply 3 by to get to 6?
2.
2, exactly. So if we put a 2 here, because now we put it in the product side where it affects the OH, this affects the AL and it affects the OH, but now OH is balanced and it's 6. That's what we call a complicated situation. So anytime you have something like this where you have to put a coefficient on both sides, I suggest that's the first one you do. All right, and if you see as well, AL is also balanced. Now, we can now focus on SO4 or we can focus on CA. It doesn't matter. I'm just going to go down the list. SO4 is, I'll just do SO4 next. We have 3 on the reactant side, but we only have 1 in the product side. Obviously, I want 3 and 3. So 1 times 3 is going to give me 3. That 3 will that way go into CA, and it will also go into SO4. And then both of those will be balanced as well. Questions? Sorry, give me 1 second. My dog's throwing up. Hold on. Sorry, guys. He ate grass, I think. When they eat grass like that, they throw up just liquid. All right. So on the basis of the general solubility rules, predict which of the following substances is likely to be soluble. So for number 2, remember I told you don't do B, but go on to number 2. There's more examples of A in the as we go on. But for number 2, You're just supposed to say if they're soluble or insoluble. Basically, again, we're using the same thing as we did for the correct states of matter. We're talking about whether it will dissolve in water or whether it won't dissolve in water. So again, you're using page 5. So the first one we have is BaNO3 So anything NO3 salts is soluble. So this would be soluble, and you would just write something like that. K2SO4, okay? SO4 is soluble. K is also soluble. So because K and SO4 are both soluble, these would be soluble. And last but not least, PbSO4. SO4 salts are soluble except when they're following. If we have Ba, Pb, or Ca, this time we have Pb. So because we have PbSO4, this becomes insoluble. Okay? And then that's what exactly you would do for the rest of these. Questions? Okay, I'm gonna do one example for number 3A, and then I'm gonna want you guys to do 3B by yourselves. So 3A, we need to write the products and we need to write the states of matter. So first things first, just like we did before, is we have to split them. Okay, and we have to get the charges for each one. So Cu, you're gonna go into your periodic table, again, the second page, because that's where you have your charges. And we have 2 Cus. I want you to notice we have Cu plus 2, Cu plus 1. You don't know which one you're using until you figure out what the charge of Cl is. Okay, so Cl, we have to go to Cl. My charge for Cl is -1. So my charge is -1 here. But I want you to notice, you have 2 Cls. You don't just have one, you have 2. So what does that mean? That means that each Cl is -1, and you have to add them together. And once you add them together, you get a -2 charge as a total charge. Right? And Cu, then that means that for Cu, since we only have one, we have to use the +2 in order to balance with that Cl. Automatically, a lot of people say C -1, and they're like, okay, if the negative is -1, then the positive has to be +1. But then they forget to check to see if there's any subscripts, because the subscripts tells you there's more than one negative charge, right? So let's keep going then. NH4. NH4 is your only positive polyatomic that's positive right there. So that would be +1. And then S is a negative. S is -2, like so. All right. So now when we put them together, Cu is +2, and remember it's outer, outer. So Cu is with S, and then inner, inner. NH4 is with Cl. So Cu +2, and then S -2. Do these balance?
Yes.
Yes. So we just need one of each, like so. Then let's do the next one. NH4 is +1, Cl is -1. Do these balance?
Yes.
Okay. So again, we just need one of each. Lastly, we need the states of matter. So we need to go back to this sheet. First, we have CUS. There's nothing about Cu at the top, but there is something about S. S is considered an insoluble compound. S is considered insoluble, meaning it won't dissolve in water, so it's a solid. NH4Cl. NH4 is soluble, Cl is soluble. That means both of them dissolve in water, so that would be where we put aqueous. And that's it. Questions? All right, I want you guys to try 3B by yourselves. Please try 3B by yourselves. All right, guys, let's look at B. BaNO3 2, K3PO4. Okay, so again, we split them up. All right, what is the charge of Ba? What is the charge of
+2.
+2? What is the charge of NO3? Charge of NO3, guys.
-.
-1. Yep. Okay, what is the charge of K?
1.
1. What is the charge of PO4?
-3.
-3. Okay, remember, it's outer, outer, inner, inner. So Ba is going to mix with PO4. Ba is +2. PO4 is -3. Now, remember, this is very similar to something we just saw above. We can't say oh, we need another Ba and that will balance with that -3. Or we can't say we need another PO4 and then that will balance out with that Ba. Instead, we need to use that technique. And someone mentioned it before. Okay. And we used it before. So what can we use to balance these charges? What can we do here to balance these charges?
Switch the charges.
Exactly. Switch the charges. So we can change them, switch them, and then this would be Ba3, right? We need 3 Bas, and then we need 2 PO4s, but make sure that your PO4s are in parentheses because PO4 is a polyatomic. Then inner inners are K +1, are NO3 -1. Do those balance?
Yeah, it is balanced.
Yes, correct. So we do KNO3. Okay. Now we just need the states of matter. So
I have a question.
Yeah, go ahead.
If the K has a 3 right next to it, why didn't the 1 change to 3?
Okay. So the reason why we have a K3 here is we have a K3 because the PO4 was a -3. So that's why we needed 3 Ks to balance with that -3. However, now K is making a new relationship. Now it's with NO3. So we don't bring over what we had in the reactants. All we bring over from the reactants is the actual element with one of its charges. So we only bring one over. We're not going to bring all 3 of them over. We only add more K if we need to add more K for the new relationship it's forming with NO3, which we don't need it because NO3 is also -1. So remember, just like in the previous one, we didn't bring 2, like for right here, we didn't bring 2 CLs, right? We only brought 1 because the Cl2 was there to balance out with that Cu +2. Does that make sense? You only bring over 1 of each and then you add more when you need more.
Thank you, I get it now.
Okay, perfect. All right, now states of matter. We have Ba3PO42. Okay, so Ba, there's nothing about Ba. We do have PO4 there. PO4 says it's insoluble, right? PO4 says insoluble. So that means that this would also be a solid like the one above. Okay, then we go to KNO3. NO3 salts are soluble. K is soluble. Both of these are soluble. So again, just like above, this would be aqueous. Okay. Are there any questions on this? All right, give me 1 second, guys, because I lost some people. Okay, I lost Anaid. She never logged back in. Sadei's still here. Naomi is still here. Brian's still here. Leslie's still here. Antonio's still here. Christian was here. Nathan is here. And then Angel is here. And then I lost. And then half again. Okay. So what we're going to be doing, guys, is we're going to keep working through this packet. On Friday, when we have everybody, we'll do the part 2. So we'll keep going with the second part. And then on next week, then we just keep going where we pick up and leave off, basically. I did record this. I'm going to post it just for anybody that wants to rewatch this. You're like, you know what? I forgot how to do that. You can see live examples, and I'm recording it for everybody, so everybody will have access to it. Okay? All right, guys, have a great day. I will see you guys on Friday.
Bye.